Ever pondered how a human brain, with billions of neurons, could possibly be replicated on a tiny silicon chip? It may sound like science fiction, but in the ever-evolving world of technology, it's an intriguing reality that's unfolding right before our eyes. Artificial neurons, also known as neuromorphic chips, are silicon chips designed to mimic the human brain's neurons. But how, you might ask, does silicon, an element found in beach sand, simulate the complex functionality of a human brain? Well, it's all about the magic of electrical circuits. In the human brain, neurons communicate via electrical signals. They receive, process, and transmit information, leading to thought, emotion, and action. Silicon chips at their core are also about managing electrical signals. By creating complex circuits on these chips, scientists can effectively simulate the behavior of neurons. In the world of artificial neurons, two concepts reign supreme: spiking neural networks and memristors. Spiking neural networks, or SNNs as the name suggests, work by creating spikes of electrical activity, much like the way real neurons do. Memristors, on the other hand, adjust their resistance based on the history of voltage applied to them. This mimics the way neurons strengthen or weaken their connections based on use, a process known as synaptic plasticity. By combining these two technologies, scientists can create silicon chips that not only mimic the behavior of neurons, but also learn and adapt, just like the human brain. But what's the point of all this, one might wonder? Surely computers are already pretty smart. Indeed, they are. But by creating chips that function more like brains, we can build machines that understand and interact with the world in a fundamentally more human way. This could revolutionize fields from artificial intelligence to healthcare, from robotics to data processing. To recap, artificial neurons on silicon chips work by using electrical circuits to mimic the behavior of human neurons. Spiking neural networks and memristors are key technologies in this process, allowing these chips to learn and adapt. And the potential applications are vast, promising to reshape our world in ways we can barely begin to imagine. So next time you're at the beach, take a handful of sand and think about this. In every grain, there's the potential for a tiny brain, waiting to be awakened by the magic of technology.